Okay, so this is the review for test number 12. All right, so for the first one is finding the limits from the graph. All right, so for the first one is to find the limit as x approaches 3. Now remember, when you find the limit, you have to make sure it approaches the same number coming in from the left and from the right. Okay, so as x approaches 3 here, so as x approaches 3, we have here, coming in from the right, as x approaches 3, I have -2. As x approaches 3, coming in from the left, I also have -2. So then my answer is -2. All right, the limit as x approaches -2. As x approaches -2 here. So as x approaches -2, I get -1, right? So my value here is -1. And as x approaches -2 from the left, it's 0. So they're two different numbers, so that means the limit does not exist. All right, next one. As the limit approaches 0 from the right. As x approaches 0 from the right, I get -1. As x approaches 0 from the left, I also get -1. So the limit as x approaches 0 is -1. As x approaches -3, so as x approaches -3, so x is approaching -3, I get 3 from the right. As x approaches -3 from the left, I also get 3. So the limit as x approaches -3 is 3. Okay, next one. As x approaches 1. So as x approaches 1, I get 2 from the right. As x approaches 1 from the left, I get -1. So that does not exist. All right, F. As x approaches -5. 1, 2, 3. As x approaches -5, I get 0. And it doesn't come in from the right. There's no graph over here, so therefore it does not exist. As x approaches 4. So as x approaches 4, now here's 4, 1, 2, 3, here's 4 right here. So there's you can't come in from the right. So you can come in from the left, it's 1, 2, 3, it's -4 here, but it doesn't come in from the right, so therefore it does not exist. All right, H. As x approaches -1. As x approaches -1, we get 1 from the right. And from the left, it's also -1. So the limit as x approaches -1 is -1. All right, so next we have f of -2. What is f of -2? So go to 2, -2 here. So f of -2, I don't want the open circle, I want the solid circle, so that's also -1. Okay, f of 4. So here's 4 here. F of 4 is 1, 2, 3, 4. -4, sorry. And f of -3, so I have this here. It's the solid circle, which is 1. All right, so let's take a look at 2a. All right, so number 2 is to determine if the function is continuous at the given value. Okay, so remember, in order to determine if something is continuous, you're going to find f of a. You have to do a couple things. You have to do f of a. You have to do the limit as x approaches a of f of x. And then you have to check to see if f of a is equal to the limit as x approaches a of f of x. All right, so let's take a look at the first one. I'm checking to see if it's continuous at x is equal to 2. So the first thing I'm going to do is I'm going to do f of 2. So I'm going to plug it into the bottom one over here because that's where I have x is equal to 2. So that's 2 minus 3 squared, which is equal to negative 1 squared, which is equal to 1. All right, now I'm going to do I'm going to do 2. I'm going to find the limit. So the limit as x approaches 2 from the left. Okay, coming in from the left, it's going to be this one here, right? Because from the left of negative 2 or less than 2. I said negative 2. It's 2. So it's going to be negative 2 plus 1 is negative 1. And then I have the limit as x approaches 2 from the right. That would be plugged into this one. And then I already know that that's 2 minus 3 squared, which is equal to 1. So first of all, this limit doesn't even exist. So the limit does not exist. So since this doesn't even exist, it's not continuous. It is not continuous. Okay, so let's check out B. Okay, so B is, all right, so I want to find to see if g of x is continuous when x is equal to 1. All right, so, g of x is 1. So g of x, so I'm going to start off with number 1. You have to do g of 1. So g of 1 is, you have your x is equal to 1 here. So that's right here. So that's just 1. So g of 1 is equal to 1. So now you have to find the limit. So this is number 2. So this is the limit as x approaches 1 from the, and let's start off with from the left. So coming in from the left, that would be this one here. So that would be 3 over 1 minus 2. So that's negative, plus 4, sorry. So that's equal to 1. And the limit as x approaches 1 from the right, so then I plug it into this one, is the square root of 1, which is equal to 1. So the limit exists. So that's good. Now I'm checking to see, does g of 1, does that equal the limit as x approaches 1 of g of x? G of 1 is 1, right? The limit is equal to 1. So this is true. So that's a check. So it is continuous. Okay, so let's take a look at number 3. All right, so it says to find the value k so that the function is continuous at the given value. All right, so you're going to plug this number into both of these, and then you're going to set them equal to each other and solve for k. All right, so we're going to do f of 2 for the first one. So it's 1/4 of 2 cubed. So 2 cubed is equal to 8, and I have 1/4 of that, so 8 divided by 4 is 2. And then I have to do f of 2 into the other one, which is k times 2 squared, so that's 4k. So then I set them equal to each other. 2 is equal to 4k, so k is equal to 1/2. Okay, so let's take a look at B. So B is same thing. I'm going to plug in 3 for both equations. So I'm going to start off with g of 3 is equal to k times the square root of 3 plus 1. So that's 2k. And then I'm going to do g of 3 for 5 minus 3, which is equal to 2. So 2 equals 2k. K is equal to 1. Okay, so let's take a look at 4. Okay, so number 4 is to find the limit. So you're going to do direct substitution. If you get a number, if you don't get anything that's undefined or anything that doesn't work, then you're good. So I have the limit as x approaches 3 of this function. So I'm going to plug in 3. So this is equal to 3 squared plus 2 times 3 minus 1. So that you could just plug in, and you get 14. So your answer is 14. So let's try the next one. The limit as x approaches negative 2. So it's 1/2 of negative 2 cubed minus 5 times negative 2. You just plug that into your calculator, and you get equal to 6. All right, so let's take a look at 5. 5 is also finding a limit. But notice what's going to happen when I do direct substitution. When I do direct substitution down here, I'm going to get 2 squared minus 2 times 2. That's 4 minus 4. That's 0. So it's undefined. So then we have to simplify this. I don't see any radicals, so this is going to be just a simplify. So I'm going to factor the numerator and the denominator. So I'm just rewriting this right now. So this is the limit as x approaches 2. In the denominator, I have x times x minus 2. And in the numerator, when you factor, you get x plus 6 times x minus 2. X minus 2 and x minus 2 reduce. So it's the limit as x approaches 2 of x plus 6 over x. Now you're going to plug in 2. So it's 2 plus 6 over 2. So that's 8 divided by 2 is 4. So your limit is 4. All right, so let's go with B now. So same thing, when I plug in 1, I get 1 minus 1 in the denominator, and that is undefined. So we're going to have to factor. So this is the limit as x approaches 1 of x plus 1 times x minus 1. That's the difference of two perfect squares. I don't know why I wrote 2. So x plus 1, x minus 1, over x minus 1. So the x minus 1 is reduced, so it's the limit as x approaches 1 of x plus 1. Now we do direct substitution, so it's 1 plus 1, and that's equal to 2. Okay, so let's take a look at 6. Okay, so 6 is also a limit. Okay, but look what happens when, for the first one, it's the limit as x approaches 3. When I plug in 3, I'm going to get 3 minus 3, and that's undefined. And I notice that I have a radical. So I'm going to have to rationalize. So I'm just going to rewrite this to start off. So it's the limit as x approaches 3 of the square root of x plus 22, minus 5 all over x plus minus 3. Okay, so I'm going to rationalize. I'm going to multiply by the conjugate. So the conjugate would be the square root of x plus 22 plus 5 over, and the same thing, the square root of x plus 22 plus 5. So the denominator, remember, you're going to leave factored. So you're going to leave the denominator as x minus 3 times the square root of x plus 22 plus 5. And remember, in the numerator, when you multiply conjugates, it's the first term squared minus the second term squared. So it's the limit as x approaches 2. So when I square this, I get x plus 22 minus 25 over x minus 3 times the square root of x plus 22 plus 5. So this here becomes minus 3. So that's x minus 3. The x minus 3 and x minus 3 reduce. So it's the limit as x approaches 2 of 1 over the square root of x plus 22 plus 5. Now you're going to plug in 2. And I don't know why, for some reason, as I was doing this, my 3 became a 2. Sorry about that. Okay, so it's the limit as x approaches 3. So it's 1 over the square root of 3 plus 22 plus 5. So that's 1 over, this is the square root of 25, which is 5. 5 plus 5 is 10, so it's 1/10. And this should be written like this, with an arrow. It equals 1/10. All right, let's take a look at 6b. Okay, so I have the limit as x approaches 2 of 2 minus the square root of x plus 2 over x minus 2. And notice if I do direct substitution, I'll get 2 minus 2 in the denominator. It's undefined. So I multiply by the conjugate. So the conjugate would be 2 plus the square root of x plus 2 over 2 plus the square root of x plus 2. So remember, the denominator we're going to leave in factored form. So it's x minus 2 times 2 plus the square root of x plus 2. When I multiply the numerators, remember it's the first number squared minus x plus 2 squared. So be careful with the numerator because in here I'm going to be subtracting a binomial. I'm going to have to distribute the negative. So it's the limit as x approaches 2 of 4 minus x plus 2 over x minus 2. And then I have here 2 plus the square root of x plus 2. So when I distribute the negative, I get 4 minus x minus 2. So then this here becomes 2 minus x. All right, so it's the limit as x approaches 2 of 2 minus x over x minus 2 times 2 plus the square root of x plus 2. Now these are actually opposites, so they reduce to negative 1. So it's the limit as x approaches 2 of negative 1 over 2 plus the square root of x plus 2. So it's negative 1 over 2 plus the square root of 2 plus 2. 2 plus 2 is 4. Square root of 4 is 2. So it's negative 1 over 4. So it's negative 1/4. Okay, so let's take a look at 7. All right, so for 7, when your limits go to infinity, that's when you're comparing the degrees here. All right, so let's see here. We have, for number 7, the limit as x goes to infinity. So I'm comparing the degrees. So this one here is, I'm comparing 2x to the 4th over negative 5x to the 4th. So when the degrees are the same, they both have a degree of 4, right? So they reduce, and what's left? Negative 2/5 is the limit. All right, so let's take a look at B. So these would be what I'm looking at when I'm comparing. So it's x to the 6th over negative 5x to the 3rd. When the degree in the numerator is greater than the degree in the denominator, it does not exist because it's going to infinity. Right, because the numerator is growing faster than the denominator. All right, and the last one here, I'm comparing x squared over 2x to the 4th. So my denominator degree is larger than my numerator degree. That means my denominator is growing faster than my numerator. That means it's getting to be a very small number. It's getting closer to 0. All right, and remember, when you do these here, they're not equations. They're just your answer, just the number. Okay, number 8 is to find the derivative using the difference quotient, find the tangent line and the normal line. So this is what we've been working on for the last week or so. Okay, so f of x is equal to x squared plus 2x minus 3. So the first thing I'm going to do is I'm going to find f of 2. So it's 2 squared plus 2 times 2 minus 3. So f of 2 is equal to 5. So I have my 0.25 here. All right, so now I'm going to start with my derivative. I'm going to start with f of x plus h. So that's x plus h squared plus 2 times x plus h minus 3. So this is x squared plus 2xh plus h squared plus 2x plus 2h minus 3. And then I have to subtract my trinomial x squared plus 2x minus 3. So let's distribute. So I get x squared plus 2xh plus h squared plus 2x plus 2h minus 3 minus x squared minus 2x plus 3. So 3 and negative 3 cancel. Negative 2x and 2x cancel. Negative x squared and negative x squared, positive x squared cancel. So I'm left with 2xh plus h squared plus 2h over h. So I reduce that there. So now I have my derivative is f prime of x is equal to the limit as h approaches 0 of 2x plus h plus 2. Plug in 0 for h, so it's 2x plus 0 plus 2. So my derivative is equal to 2x plus 2. Okay, so now we have to find the slope at 2. So my slope at 2, so this is f prime of 2 is equal to 2 times 2 plus 2. So that is equal to 6. So my slope is equal to 6, and the point is to 5. All right, so now we're going to come up with the tangent line. So that is y minus 5 equals 6 times x minus 2. That's y minus 5 equals 6x minus 12. Y minus 6x equals, add 5 to both sides, and we get negative 12 plus 5 is 7. Okay, now my normal line. So that's y minus 5 equals negative 1/6 times x minus 2. So cross multiply, we get 6y minus 30 equals negative x plus 2. 6y plus x equals 32. Okay, so let's take a look at 8b. Okay, so I'm going to start off by first finding f of 3 here. So that's 3 times 3 squared minus 4 times 3 plus 2. So f of 3, I got 17. So I have 317 here. All right, so now let's start with f of x plus h, which is 3 times x plus h squared minus 4 times x plus h plus 2. So that is 3 times x squared plus 2xh plus h squared. So that is 3x squared plus 6xh plus 3xh squared minus 4x plus 4h plus 2. And then I have to minus 3x squared minus 4x plus 2. And then I get negative 3x squared plus 4x minus 2. Okay, so negative 2, positive 2 cancel, 4x and negative 3x squared and positive 3x squared. So then I'm left with 6xh plus 3h squared plus 4h all over h. So it's the limit, f prime of x is equal to the limit as h approaches 0 of 6x plus 3h plus 4. We plug in 0. So I get 6x plus 3 times 0 plus 4. So, oh, what happened? Let me redo that. I'm not sure what happened right there. It's weird. Almost looked like Long Island. All right, so f prime of x is equal to the limit as x approaches, h approaches 0 of 6x plus 3h plus 4. Plug in 0 for h, so 6x plus 3 times 0 plus 4. So my derivative is equal to 6x plus 4. All right, so I just realized that this 4, because I can't even read my own handwriting, should have been a plus in here. And then this here should have been actually -4. Sorry about that. This should have been -4h in here. This should have been -4, and then this should be a -4. All right, so now I'm going to do f prime of 3. So it's 6 times 3 minus 4. So f prime of 3 is 18 minus 4, which is 14. Okay, so my slope is equal to 14. Right, so this was 14. What the heck? Oh, jeez. 14. All right, so my slope is 14, and the point it's going through is 3, 17. So I have y minus 17 equals 14 times x minus 3. And you guys can simplify that on your own. That's the tangent line. My normal line is y minus 17 equals -1/14 times x minus 3. And you guys can simplify that on your own also. Okay, so let's take a look at number 9. Okay, so number 9 is, 9, 10, and 11 are all review type of problems here. So let me rewrite this. We're solving for x, exponential equations. Remember, what you want to try to do is get the same base. So it's 1/2 raised to the x plus 2 equals 8 raised to the 3x plus 6. So what you want to do is get the 2 out of the denominator. So that's 2 to the -1 raised to the x plus 2. All right, so then this here is 2 to the -x minus 2 when I distribute the negative. 8 with base 2 would be 8 to the 3rd, 2 to the 3rd raised to the 3x plus 6. So this is 2 to the -x minus 2 equals 2 to the 9x plus 18. So -x minus 2 equals 9x plus 18. So then we solve this. Add x minus 18. I get -20 equals 10x. So x is equal to -2. All right, so let's take a look at b. So b is 1/9 raised to the x minus 2 equals 1/27 raised to the 2x minus 1. So I want to change both of these here. So this is 9 to the -1 raised to the x minus 2. 27 to the -1 raised to the 2x minus 1. So that's 9 to the -x plus 2 equals 27 to the -2x plus 1. So 9 would be base 3, so it's 3 squared to the -x plus 2. So that's 3 to the -2x plus 4. 27 base 3 would be 3 cubed raised to the -2x plus 1, which is 3 to the -6x plus 3. So now I have -2x plus 4 equals -6x plus 3. So I get, so I'm going to add 6x to both sides. I get 4x. Minus 4 from both sides. I get -1. So x is equal to -1/4. Okay, so let's take a look at 10. All right, 10 is a log equation. So what you want to do is you want to simplify the logs. So you're going to condense this. A plus comes from these two being multiplied. Now, since there's log only on one side, you have to put in exponential form. So I'm just rewriting this now. Log base 3 of x plus 24 plus log base 3 of x equals 4. So the plus comes from them being multiplied. So it's log base 3 of x times x plus 24 equals 4. Since there's log only on one side, you have to put in exponential form. The base is 3, so it's 3 to the 4th. These two like switch places. Equals x times x plus 24. So you're going to distribute. 3 to the 4th is 81 equals x squared plus 24x. 0 equals x squared plus 24x minus 81. Factor. You get x plus 27 times x minus 4. T-chart, you get x equals -27, x equals 4. You have to check these. So you just use your calculator, plug it in, and check it. Use log base. This one actually doesn't work, -27. All right, so let's try B. So that's log base 2 of x minus 5 plus log base 2 of x minus 9 equals 5. Again, we're going to condense. So I have log base 2 of x minus 5 times x minus 9 equals 5. Take it out of exponential, it's 2 to the 5th equals x minus 5 times x minus 9. So 2 to the 5th is 32. Distribute, we get x squared minus 14x plus 45. So I get 0 equals x squared minus 14x plus 13. Factor, we get x minus 13, x plus 1, x minus 1. T-chart, we get x is equal to 1 and x is equal to 13. Check it, this one does not work. Okay, so for the last problem is the complex fractions. Sorry, you're going to hear the announcements over me. So the first thing I'm going to do with the complex fractions is separate the numerator and the denominator. So it's a over b minus b over a, right? And then I have my bar divided by 1 plus a over b. So in order to add fractions, you have to have the same denominator. So I multiply top and bottom by a, top and bottom here by b. I get a squared minus b squared over ab. Divided by, multiply top and bottom here by b, b plus a over b. Now I could do same change flip. I get a squared minus b squared over ab times, flip it, b over b plus a. Now we can factor, this is factorable. That's the difference of two perfect squares. That's a plus b times a minus b over ab times b over b plus a. A plus b and b plus a, same thing, they reduce to 1. B and b reduce to 1 and 1. So I'm left with a minus b over a. Okay, so let's take a look at the last problem. So I'm going to start off the same way. So I have x plus 1 over 2 divided by x squared minus 1 over 4. So I'm going to multiply numerator and denominator by 2. So it's 2x plus 1 over 2 divided by, multiply top and bottom here by 4. 4x squared minus 1 over 4. Now I could do same change flip. So I have 2x plus 1 over 2 times 4 over 4x squared minus 1. So 4x squared minus 1 can be factored. So I have 2x plus 1 over 2. Times 4 over, this is the difference of two perfect squares, 2x plus 1 and 2x minus 1. So 2x plus 1 and 2x plus 1 reduce to 1 and 1. 4 and 2 reduce to 1 and 2. So I get 2 over 2x minus 1, and that's my final answer. Okay, so that's it, and happy studying. Have a good night. See you tomorrow.